In this module, let us explore C pointers and functions, focusing on how to pass variables by reference. We will understand what pointers are and why they are useful when working with functions. Firstly, let us understand the difference between pass by value and pass by reference. Here is an example of pass by value. The code defines a function called increment that takes an integer number as input. Inside the function, number is increment by 1. However, this change is local to the function, and the original variable remains unchanged. In the main function, an integer x is initialized to 5. The increment function is called with x as the argument. After the function call, x is still 5 because increment only modified a copy of x. When passing by value, the function receives a copy of the variable. Changes inside the function do not affect the original variable. This is the default behavior in C. Now let us look at passing by reference using pointers. This code shows how to increment a variable using pass by reference. The increment function now takes a pointer to an integer, number ptr. Inside the function, the value at the address pointed to by number ptr is increment by 1. This directly modifies the original variable. In the main function, an integer x is initialized to 5. The increment function is called with the address of x, obtained using the ampersand operator. After the function call, x is now 6 because the function modified the value at its memory address. When passing by reference, the function receives the memory address of the variable. Use the ampersand operator to get the address and the asterisk operator to access or modify the value. Changes inside the function directly affect the original variable. Pointers can also be used to modify multiple values within a function. Take the example of swapping two values. The swap function takes two pointers to integers, a and b. Inside the function, a temporary variable temp stores the value pointed to by a. Then the value pointed to by a is replaced with the value pointed to by b, and the value pointed to by b is set to temp. This effectively swaps the values of the original variables. In the main function, integers x and y are initialized to 10 and 20 respectively. The swap function is called with the addresses of x and y. After the function call, x is 20 and y is 10. Pointers allow functions to modify multiple variables. The swap function illustrates this capability. Without pointers, swapping would necessitate global variables or return structures. Passing by reference is more efficient for large data structures, as it avoids copying the data. Arrays and pointers are closely related in C. Here's how you can modify arrays and functions. The double elements function takes an integer array ARR and its size as input. It iterates through the array, doubling each element. The original array is modified directly. In the main function, an integer array numbers is initialized with values 1, 2, 3, 4, and 5. The double elements function is called with numbers and its size. After the function call, numbers becomes 2, 4, 6, 8, and 10. Arrays are automatically passed by reference. When you pass an array to a function, you are actually passing a pointer to its first element. You don't need to use the ampersand operator with array names. Array notation ARRI is equivalent to asterisk ARR plus I. Let's cover some best practices and common errors when working with pointers. Some best practices include: always initialize pointers before using them. Check for null before dereferencing a pointer. Use const for pointers that should not modify data. Free dynamically allocated memory to avoid memory leaks. Use meaningful names that indicate the variable is a pointer, for example, p-value or value ptr. Some common errors include dereferencing null pointers, which causes program crashes, dangling pointers which point to freed memory, memory leaks which occur when you don't free allocated memory, buffer overflows which involve accessing beyond array bounds, and pointer arithmetic errors, which are due to incorrect calculations. Pointers enable powerful memory manipulation in C, but require careful handling to avoid common pitfalls. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.